Hello, I'm Erica Meeker, and this is my presentation on the PCI Big Beam Competition. I'm with Bold City Bridges Group from the University of Central Florida. Based on the design criteria of a 20-foot long beam loaded with either a 32-kip factored load or a 20-kip service loading, this is the cross-section chosen. This is a 28 IT 24 beam with 5,000 PSI concrete strength and 20 half-inch diameter low relaxation strands. The center of the strands was determined to be 3 inches from the bottom of the beam through calculations of the cross-section selection. Through the analysis, the beam can withstand an ultimate loading of 40 kips and has a cracking load of 21 kips. Also, based on this ultimate loading, the max deflection at the midspan was calculated to be 0.01 inches. Here is a design sketch of the flexure design. Here you can see all 20 strands spaced at 2 and 11/16 inches with a 2-inch clearance. Also, here you can see the center of gravity of the strands to be at that 3 inches from the bottom of the beam. The shear design was also checked. It was determined that the shear strength required is met by the concrete strength. However, for a cracking design, number 5 grade 60 bars were used at a 12-inch spacing. Here, that spacing can be seen in this elevation view. Here you can see the design sketch of the shear design. Again, the use of a 2-inch clearance was used. To make sure both the web and flange were protected against cracking, this rebar shape was chosen so that the rebar is both in the web and the flange. Once the design was complete, the cost of the beam can be estimated. The items in this beam are regular strength concrete, half-inch diameter pre-stressing strands, and grade 60 steel. Based on the cost set by the PCI Big Beam Competition and calculating the quantities based on the design, the total cost of the beam is about $628. After the design of the beam, there were a few lessons learned. First, I learned that the section modulus design had the controlling design criteria on this beam design that was calculated in the cross-section selection. Second, I learned that in this design, the concrete strength was more than adequate in resisting shear, but the crack control required the addition of shear reinforcement. Finally, through this design, I learned that there were a lot more factors needed for a pre-stressed beam design than a reinforced concrete beam design. Mainly, the steps involved in the pre-stress loss determination, including humidity index, as well as any time-dependent variables. Here are the references used in this beam design. Thank you.